Hello, my name is Leo. Today we're going to talk about algorithm. When you hear algorithm, what do you think about? Well, most of us think about way or method of solving some problem. And this is the base of algorithm definition, but some other details also have to be stated in algorithm definition. There was old Persian mathematician called Muhammad ibn Musa al-Khwarizmi, after whom algorithm got its name, so after his surname al-Khwarizmi. And he was a mathematician who explained calculations in decimal number system. However, today we do not use only decimal, but also binary, octal and hexadecimal number systems, which are especially used in computer representing data. Throughout history, mathematicians were those who observed algorithms, and today they also have a very important role in observing forms and characteristics of algorithms, but they're also computer scientists who apply these algorithms into real-life situations and to solve some given problems. How is an algorithm created? There are many ways how can an algorithm be created. First way is by experience and observation, and these are called imitation algorithms, and are mostly used in physics and other natural sciences, so as to describe some acting, behavior of some natural phenomena and relations between some physical quantities. So we have lots of formulas in physics which are actually algorithms which imitate nature around us. There are also theoretical algorithms which are primarily based on theory and are therefore mainly used in mathematics, which has lots of theory, and in other sciences. Construction algorithms are those which are connections of two or more existing algorithms, and in this way we get only one algorithm which serves some purpose so as to solve some task, some problem. And finally, here is the completely different way of creating algorithm, which is algorithm as a product of human creativity and imagination. Let's define algorithm by its characteristics. Firstly, algorithm has to be unambiguously defined. This means that algorithm should serve the purpose it serves for, and it should be clearly understood and defined. Now, it has to have clearly defined initial start states of objects. Also clearly defined final states of objects, also called results. Algorithm has to have finite number of steps, and steps are those which determine operations on objects. So these operations have to perform on the objects in order to get some final states of objects. Every step is described by some instruction that has to be performed, executed in processor. There are some commands which are not instructions but commands like if statement, for and while loop, etc., which are used in programming languages, so in computer programming, and they give certain directives to computer program for performing some certain task. The algorithm performing process is called algorithm process. Finally, this last characteristic of algorithm is that it ends in reasonable time. Here are some three very important terms related to algorithm characteristics. First is algorithm correctness. We say that an algorithm is correct if only from all object input states which are allowed from the domain of mathematical function with which algorithm is defined, so that for all of these input states it enables us to determine their final states, so results of these objects, and if results are correct for all possible object input states, then we can say that algorithm is correct. So simplified, algorithm is correct if there are always the same outputs for the same given input states of objects. Therefore, every algorithm has to be tested on some tests, on some checks. Let's, for example, take an example of algorithm which has domain of natural numbers between 1 and 10, including them. Then it has to be tested on some values, including these 1 and 10, which are so-called critical or limit values. There is also time complexity characteristic, which says us that the duration of algorithm process is proportional to the total number of operations which has to be performed. And this is one of the main algorithm characteristics when we have two or more equivalent algorithms, so we have to choose which one is best to serve its purpose. And equivalent algorithms are those algorithms which give the same final states of objects for the same start states of the same objects, and those which have the same domains of allowed objects. If we, for example, have two equivalent algorithms, then in most cases we choose the algorithm of smaller time complexity. And finally, algorithm depends on data structure, and data structure are ways of presenting and storing data. And algorithms and data structure are often considered as only one unit called program. And program is collection of instructions implemented in a programming language using commands which are given to a computer to be executed. Here are the three basic types of algorithms, primarily based on characteristic of algorithm correctness. First, algorithms are deterministic algorithms. These are those we are mostly talking about and that are mostly used in computer programming. So deterministic algorithm is this which produces always the same output for the same given input states. And there are input data that the deterministic algorithm uses, and this input data define the domain of mathematical function which is computed in algorithm. And deterministic algorithms can be defined in terms of so-called FSM, which is finite state machine or automaton, also called only state machine, which is a mathematical computation model used in computer science and in sequential logic circuits, which is a machine that has finite number of states and only one state at a given time, which is called current state, and this current state can be changed by an event called transition. Here we have also randomized, also called Las Vegas algorithms, which have which employ some degree of randomness. So they randomly pick input states, but output states are always correct according to the same input states. So it has this correctness characteristic of algorithms, which is very important in phases. And they are sometimes used instead of some deterministic algorithms, such as quicksort algorithms, algorithm used for sorting, because there is high probability that this quicksort algorithm implemented as a randomized algorithm, which will have the much smaller time complexity than deterministic algorithm, equivalent deterministic algorithm. And finally we have this probabilistic, also called Monte Carlo algorithms, which need to be differed from these randomized algorithms, because they not only pick randomly their input states of objects, but they also have some degree of some probability that output states will be incorrect. It is not the high probability of incorrect output states for the given same input states, but there is some. It is also used in some cases, such as, for example, approximation of pi constant value. Now you've learned what algorithm is and about the basic characteristics of algorithm. In one of the next videos you are going to see some of the basic examples of algorithms which are very commonly and frequently used in computer programming. Thanks for watching and stay with us.